This conference will now be recorded.
Very good evening, students. We have been discussing electricity chapter, electric current. So today we'll be learning a very important and very interesting topic, that is electrolyte cell, EMF, internal resistance, and combination of cells. So this is a very important topic, and there will be at least one question from here. And obviously the concept of this combination of cells will come in work while discussing Kirchhoff's law. Okay, so better to learn the cell, electrolyte cell here nicely. Okay, so if you can just see, this is a schematic diagram of a electrolyte cell. See, what are the components of this electrolyte cell or structure, or how is it constructed? See, there will be metal electrodes. So these are metal electrodes, and those metal electrodes will be dipped into the electrolyte. As you see here, electrolyte can be AgCl, CuCl, etc. So that depends like what we want. According to that, this electrolyte is selected. So this electrolyte is actually a solution, okay, solution or liquid. So liquid electrolyte will be there, and this will be a container, sometime lead container or something. Okay, and see, these are two metal electrodes which are dipped inside the liquid electrode. And see here, let us suppose this electrode has, like, it is at positive potential with respect to the point A, which is inside the electrolyte. I mean to say, the potential of P is positive, or its polarity is positive with respect to the nearby or nearest layer of electrolyte. Similarly, this N, electrode N, is electrically negative, or it is negative compared to the point B here, which is inside the liquid or inside this electrolyte. So let us say this point A has some potential. A has potential positive, so this is V plus potential. I can write also VA is equal to this. And potential at B point is some negative potential like this. Then what is the potential difference? What is the potential difference? It will be, suppose V, which is V plus minus of V minus. So this is V plus of V minus. So this is actually the potential difference between the points A and B. Okay. All right. So now, if we see here, this uh, actually this potential difference VA and minus BB, this is actually called as electromotive force. Electromotive force. Okay, this is called electromotive force. When these electrodes are not connected with a resistor, or when the cell is at open circuit condition, the cell is at open circuit condition, open circuit condition, then the potential difference between the electrodes condition, when the cell is at open circuit condition, then the potential difference between potential difference between A and B is called, or potential difference between the electrodes. Okay, potential difference between the electrodes, also we can say electrodes, between the electrodes is called the electromotive force, EMF, or electromotive force. Electromotive force. So do you think this is a force? It is just named as electromotive force. It was given this name when the phenomenon of electricity was not very much understood. Okay, so EMF is the potential difference between the electrodes when the electrodes are, or the cell is not in closed circuit condition, or when it is in open circuit condition. Okay, all right, so far we are all right. Okay, with this, so we have learned what is EMF. EMF is denoted generally by E. So this is EMF. Okay, generally it is denoted by this symbol. Sometimes people may write this also. This basically are same. Okay, so if we now connect these two electrodes with a resistor R, then what is the chance, or what is the thing happening? See, first of all, I just forgot to tell you why do we need this electrolyte cell or any kind of cell. See, cell is required to get an uninterrupted flow of current, uninterrupted flow of current. Okay, so this is a requirement of the cell. So cell is required to get uninterrupted current through it, or unwanted, like uninterrupted service from any electronic devices or electrical devices. All right, so far we have learned that when at open circuit condition, we see that VA minus VB gives you this. Now suppose the ends of the the electrodes are connected with a battery, sorry, with a resistor having resistance capital Q, capital R. So what will happen? There will be flow of current. Since there is a potential difference between this P and N, potential difference between P and N, then there will be obviously a flow of current, and that flow of current is suppose I here in the circuit, and that current will flow outside the circuit. As you see from C, the current is I is flowing from C to D. Okay, but what happens? See, there will be kind of a closed circuit inside the liquid also. So the current is flowing in this way, C to D, but inside the electrolyte, there will be again flow of current, but the direct same current will flow in the opposite direction. See, this is because electrodes exchange electrodes. How do we get current? Electrodes exchange the charges, which cause a flow of current. That we can write anyway. So electrode inside the electrolyte, they will exchange the charges. Okay, so therefore there will be a flow of current. Okay, there will be flow of current. Alright, this flow of current will be in the opposite direction, D to C, like this. Current will flow like this. And as you know, since current is flowing through the electrolytes also will offer a small resistance. So offers a small resistance to the flow of current, flow of electric current inside the electrolyte. Okay, inside the electrolyte. So this electrolyte will offer a small resistance, let us say the small R, which will oppose the current which is going through this. Okay, okay, so now see the potential difference across the conductor. See this across P and or let's say potential difference between B and potential difference between C and D, or maybe we can say P and N. So what is that potential difference? That will be now in the closed circuit condition. V is equal to I into R, that is there. See, since this is current in the opposite direction, that will be actually, see, effective potential will be across this potential, sorry, electrodes will be E minus. This will be small r. Okay, so we get this effective potential when the electrodes are connected to each other. And see, from here also we get a relationship between V, the potential, this is electromotive force, this is the loss in the loss in the loss in the internal resistance. Okay, now the circuit symbol for this cell is actually given here. All right, so we have got the relation V is equal to this is the relation we have got. I'm sorry. E is equal E minus Okay, so we'll go to the next. So we have got a minimum idea of what is called internal resistance, EMF, and cell, and its circuit symbol, etc. We have learned. Now, combination of cells. See, sometime our desired voltage or potential difference may not be obtained by using using one or two cell, and for that actually we need to use several number of cells together to get the desired amount of uh, okay, so we need to have a combination of cells. Okay, now we'll see combination. Okay, so combination of cells generally of two types. One is series combination. Okay, series combination and parallel combination. Okay, so first we will discuss about series combination of the cells, and then we'll go to the series combination. So just like your resistor, you can arrange them back to back like this. Here you have to remember that the resistive terminal has gone to the positive. So in series combination, just like resistor, we have to check what are the things here. One thing is that here you can see in the series combination, always you see the negative terminal will be connected to positive terminal of the other battery, other cell. Okay, so this is one point how to make series combination of batteries. So positive terminal of one battery will be connected to negative terminal of the other battery. So this is actually, these are supposed to cells having EMF E1 and internal resistance R1, and this is E2 having this similar composition E2 epsilon 2 or E2 R2. Okay, so now if we connect this to some circuit, you know what will happen. So let us just derive what is the potential difference between, say I have 3 points here. So look here, this is A, this is B, this is C point. I have to find out the potential difference between these A and C. Between A and C, potential difference. My aim is to find out what is the potential difference between A and C. Okay, that is what I need to find out. So to find out this, look what we have to do. Here you can see I can write potential difference between A and C is C V A minus BB then VB minus BC. Okay, this will ultimately give you VAC. But what is VA minus VB? That means the potential difference across this across the uh, across the cell E1, the terminals of the C1, and this VB minus VC is the potential difference between B and C points. Okay, so now see VA minus VB is what? VA minus VB, we have seen this will be E1 minus I R1. Okay, and this should be again E2 minus I Now see, if I do this, E1 plus E2 minus I into R1 plus R2. Okay. Okay. So in series, we see how the internal resistance are contributing here. So we can see this could be still understood, but what about this? So if we replace this, see the combination of these two cells with a single cell, what we get actually? See, for this we can write VAC minus VA minus VC. VA minus VC, that is here actually epsilon minus or equivalent. Okay, so this is actually the equivalent. Okay, so what I'm trying to say is that now we'll compare this to this one. So here it will be okay. So we'll go to the next page. So we have seen that so equivalent EMF is actually U1 plus E2. And equivalent resistance will be, so this is, I'm sorry, not this one. R equivalent is equal to R1 plus R2. Summation of the, okay, so in series combination, both are actually additive. EMFs also and the internal resistances also are additive in nature. But one thing you should remember, suppose battery is connected like this, battery is connected like this, If this, suppose this as E1, R1, E2, R2, so in that case, see this is U1, say okay. So the total potential difference between this point and this point will be, see, epsilon 1 plus epsilon 2 plus, so this is actually equivalent appointment. Okay, so here you have to carefully take the sign of battery, sign of resistor, etc. Like while current flowing. So this is the thing. I'll discuss this later when we go for numerical problem. Now I'll see parallel combination. I'll write it here, parallel. So parallel combination. Okay, so in this case also let us see there are two cells E1 and E2, their respective electromagnetic force, and R1, R2 are their respective internal resistances. So you can see that B1 and B2 points, when current has actually four paths here. So here you can see that the current or charges which are coming up to here, they are actually getting divided into two parts. One part is going this way, another part is going this. That's why I1 and I2 currents are there. Now look, if I write potential difference between V and VA and VC, so this could be written as VB1 minus VB2. So in this case, look, let me see, since this potential difference between B1 and B2 are the same, so I'll take uh, so let us denote this as VB minus VB1 minus VB2. Okay, now see this, since this lower branch also at the same terminals of B1 and B2, so the potential will be same for both of them. Okay, so in this case, you look what happens. So VAC you have to calculate. So say this one is, see B will be, suppose I just consider U1, so this will be U1 minus according to figure this one, and this will be E2 minus IR2. Okay, so from here we can actually find out what is, see, the one more condition is that one at this branch 1 plus 2. Now I know I1 is equal to I1 plus I2. So we have to solve for I1 and I2. If we solve for I1 and I2, look what we are going to get. Okay, so I1 will be, see here, I1 will be, similarly I2 will be, so I1 plus I2. So if we add them together, I1 and I2 is equal to I. So what is I1 and what is I2? That we have to put it here, and then we have to get a relationship. Okay, we have to get a relationship between EMF and battery, etc. Okay, I think we'll stop it here. We'll just do numericals and this part. Uh, there is some, I think there is some technical issues. We'll just continue this class tomorrow again. Thank you for your patience. Bye for today.